Well, ladies and gentlemen, with rapidly evolving technology, the way we train seafarers is undergoing a transformation. Maritime simulation is no longer just about traditional bridge and engine room training. It now integrates AI, VR, and real time data analytics to enhance decision making, safety, and operational efficiency. The question is, how do we ensure that training solutions keep pace with all these advancements? Well, to shed light on this, we have with us a distinguished guest, a global leader in maritime technology and training solutions. He is an industry expert in advanced simulation, based training, and technology driven learning solutions for seafarers. With extensive experience at sea and ashore, he has been instrumental in developing next generation maritime training programs that align with the evolving needs of the industry. His work at Wartsila focuses on enhancing competency development through innovative simulation techniques. Ladies and gentlemen, put your hands together and welcome Captain Gaurav Bajaj. Captain Gaurav Bajaj, please come up on stage.
Good evening, everyone, and thank you, Naval Connection, for getting such a vibrant audience in one room and in such an exotic location. So, always a pleasure, Shaukat sir. So, what I'm going to speak today, I've been speaking in many conferences about technology, all that. So, I thought, why not speak about something which nobody is speaking? Or maybe let's not take credit. Some people are speaking. So we have talked about simulation, we have talked about a lot of technologies, but there are some emerging technologies coming right now, and I would say next 5 years, not even very far. So these are basically identified gaps or industries which were kind of within the national territory is now turning international because IMO is getting involved. So let's step into the land of unknown and let's talk about some things which very few people are talking about and probably will be the forefront of things in next 5 years to come. So let me start. So basically my presentation is two parts. So there are two avenues where training solutions are needed. It's a need of the industry out of modernization or out of the trade that is coming into. So part one deals with passage planning. So we have a lot of people from educators, universities, which are still using paper charts. So my question to them is, where are the charts? Which we will see in the third part of my slide. So in a few years' time, you won't find any. Right now, most of the ships have already working on the EGDIS and turned to digitalization. So the whole part of what you teach in academia is not matching what they do on board. So when they do go on board, they are probably using planners, they are using EGDIS, they are using all these IBS systems, but I mean, you are still practicing everything on paper charts with set squares and everything. So let me go ahead. So you can see a wide difference between what you see on top. So traditional ships, some of us might relate to that. And the modern ships down below with all the latest tools, IBS systems. So gone are those tables and publications or manual fixing that we used to do. So syllabus is changing, but it's not changing in that rate. Now we have references to passage planning in many of the regulations. So whether it's ISM, whether it's STCW, it's SOLAS, so everywhere there is reference of passage planning. Some places there is reference to even keeping charts and publications physical. Now this is the most interesting slide of the whole presentation that I have created. Some facts. Traditionally paper charts were being used. Report indicates that about 90% of the ships by 2026 will go digital. 80% already done, 10% probably inland, and a lot of these places which were not done hydrographic surveys are now turning digital. So a lot of these inland waterways also now turning digital. So you mean to say 90% of people are using electronic methods of navigation or passage planning. We are in constant talks with UKHO. So a lot of meetings have taken place. So they were supposed to phase out the paper charts by 2026, but there was a request for many of the member states, so they have to honor that. So by 2030 is something that they are saying that it will be phased out. The next line. So this is the screenshot which I have taken from NOAA, which says farewell to traditional nautical charts. As on December 31st, 2024, they have stopped publishing any paper charts, any raster charts, everything is stopped. So it's total digital in US and US waters. So this screenshot, the blue one, is actually a screenshot from their website. So they have sunset everything. Now there are no paper charts anymore. So forget about US training charts and everything, nothing will be available. And soon to be your UKHO. UKHO means which represents most of the nations anyway. S100 also is coming in, which again gives a push to the digital move for navigation. S100 are the new requirements which from 2026 will come into hybrid mode, and they say about 1st of Jan 2029 in full force. Right now, I think only Canada, US and a couple of European countries are publishing the charts. Right now, nobody is ready. So that's the time we have. That's why I said we have 3 to 4 years. That's about it. Then you have STCW meetings taking place at IMO, and I'm very delighted that actually a lot of people sitting here have represented India and put down their papers regarding this. But I'm not sure whether anybody has put this as an identified gap. Because by the time STCW will come out in 2029, this will already be a gap. And you can't make any changes for next 5 years. So I hope and I request someone to take a lead and push this through. It's nothing to do with, it's basically it's the fact. I mean, the charts are going. You can see it's already going. I mean, once UKHO stops, it's all gone. So S100, we talk about a lot of things on S100. So S100 is nothing but a culmination and combination of various agencies coming together and presenting you a chart where you get all the information at one place and in 3D. So whether it's bathymetry, whether it's navigational warnings, whether it's dive warnings, whether it's to do with VTS, all these things will be available. So there are standards to it which are going to be implemented by 2029. So you will find the ecdysis changing from something like 2D on top to 3D. So you will have a 3D layers where you can see the actual bathymetry and you can even ping them. So, I mean, you don't have to actually consult the publications anymore. Everything will be integrated. Okay, so let's talk about the solution that Wartsila has right now and is already running on ships. It's running on fleet monitoring centers ashore. It is running on weather optimization companies. And I'm sure a lot of other manufacturers are following that. So this identified gap is already plugging in a way, but again, we are not talking about type specific training. What I'm here to talk about is STCW training. So let's not think in lines of what the manufacturer, because type specific training is very common. Everyone does that and everyone has to do that. But let's talk in terms of how your base will change when the chart work or whether the passage planning which you used to do on charts, paper charts, will now shift to digital, and what tools and what extra things you have to do that. So some examples, just screenshots on what all things that are available and the tools that you can actually use to conduct a full voyage planning on digital web. So ashore, if you see, it's a FOSS dashboard which many of the companies are using for monitoring of ships, for guiding the ships, for optimization, fuel efficiency, decarbonization. So it's a big push for decarbonization. That's the whole idea. That's the whole keyword, I would say. It's being used by weather optimizing companies also as such. I mean, it is used as a new kind of job profile. Many people are getting employed on that. Many companies are coming up for that. In addition to monitoring of engine parameters that many of the performance monitoring agencies are doing. So this is a sample of a fleet operation center. What happens, how they guide the ships, how they monitor the ships. So all the assistance that you can get is again a push towards optimization, efficiency, and decarbonization. These are a couple of features that are available at NaviPlanner. So you have intelligent routing, you have publications, tide tables integrated, you have DUKC calculations, which again take into account all the tide. You have many options for just-in-time arrivals, most economical speed, fastest arrival. You have a playhead function, you have nav area warnings, and many more functions. Just some couple of screenshots from there. So this is the home page. This is a planning window. So basically the database of all the ports are also inbuilt. So you can actually put one port name and destination port name and you will get the most optimized route. You can just have to connect online, take subscription of a weather observing agency and you will get that. Then charts and publications also can be directly connected and directly ordered. So once you plan a passage, it will highlight what all charts you don't have and you can order it automatically. So this is the interesting one. You can see these are various comparisons. This is the original route, what you had plotted. This is the fastest arrival. The second one is economical. And just in time is basically when you are feeding the ETA, it is giving you. So you see the actual route being done is not a straight route what we were so used to doing it. It's actually a zigzag path, which you will think it's just crazy. I mean, why you will follow a zigzag path across the ocean? But then again, this is the best and the safest mode to do it. You will be taking advantage of the tides, the winds, you will be burning less fuel, and you will be arriving before time by doing just this. So these are the weather routing options. Nav area warnings, environmental warnings, storm warnings. Now, the core part. We talked about what we are doing on board. Now let's talk about what we want to do ashore. Because we are doing nothing so far. This equipment is there on board, a person goes there, learns it through a user manual or maybe a type specific training. But when cadets to that level are doing it, they don't know anything about this. Probably the first time they will come to know what is a digital passage planning or what kind of a system is this, weather optimization, just in time. These are the words probably they will hear when they go on board. Or maybe some things are being covered, but then not the practical aspects of it. So what we are doing right now is Wartsila did a lot of conferences all across the world, US, Europe, Mumbai, Philippines. We collected a lot of data. So some were users, some were from academics who just highlighted what problems they have, what do they have right now, what they are doing to do about it. So we collected a lot of data. And now we are creating an MVP. So basically we are creating definitions for the product, how the product should look like. That's the second step. So what we think is the biggest challenge with education institutions is basically cost. First and foremost, subscription of all these things. I mean, live charts, live weather optimization, all that stuff really costs money, and that's like a recurring stuff. So we need to do something about that and probably have a fixed data set which can be erased after a training and then reset. So basically then you know what kind of training and what kind of, so even the instructor is prepared. Because if I take today's weather and try to teach something, and maybe after 6 months it will give a different weather if I take a live weather. Then probably the instructor will feel embarrassed because he doesn't have answers to it. So we need to have some kind of a system. It's not easy, but yes, we are thinking on those lines. So all these overlays, charts, ENPs, intelligent routings, optimization data. So maybe it's possible that some part of it might have to connect to internet to basically get the advantage of the AI, which goes behind the scenes to actually do that route. So that's possible. So we'll have to find a way around that. Because right now on board, it's a live data, it's a live streaming, and it's all dynamic answers depending on the situation. So deployment method, we are thinking in lines of physical classrooms, could be cloud because there'll be a lot of people to train. So for mass trainings, we think cloud is the best option. If it is again approved by STCW as a mode of training, which probably they are thinking now, that cloud should be an approved method of doing that. We can do it with the student-led exercises, predefined exercises. So what are the main considerations? If you see down, so basically data reuse, data spoofing. So this is something interesting which came from one of the shipping companies that, what about data corruption? You have to simulate that. I mean, what if it is not updated in a proper way? So a person, a human, should basically challenge what the system is doing. That's what we don't do. We normally accept everything. I mean, on a phone or on a map. People are flying all over the flyovers to ditches and dying just because people blindly follow Google Maps. So basically what people need to understand, they have to develop skills to challenge the system. If a system is giving you an output, you have to understand why it is doing that. That's the core of it. You may not have an intelligence for it, but then you can challenge it and you can probably deduce something out of it that, okay, probably this is why it is asking me to divert. I mean, we used to do a lot in olden days when there were no faxes and all that, so meteorology was, so I think we are actually kind of going away from the core values just by modernization part of it. So some renders of what training solutions. So this could be a hybrid solution till the time charts are there, next 2-3 years. So there could be a chart, there could be few screens for comparison, how the system will, you can do the parallel on a paper and on the screens as well. We have already made these tables. So these are chart planning tables that is already available and being supplied on board. So these are planning tables which Wartsila is supplying. So now we are even planning to, and Wartsila has supplied to many of these training organizations in Europe as well. So these tables are exclusively being used for trainings as well. But then it's real life training, what you will do on board. So it's more for a type specific, I would say. Now this is something which we are aiming for. A full classroom with individual tables to practice, with individual data and maneuvering of the vessel. So that's how we do the EGDIS simulator now. But then probably this is how we'll do the Navy planner. So this we are only talking about the planner. I'm not talking about the EGDIS at all. I'm only talking about planning. Execution is easy. Once you have done the planning, you just press execute and go to monitor mode and it's done. So the whole challenge of the steps of basically appraisal, all those things is actually the planning. Now, this is a dashboard which, or I would say sticky notes, which give you what we collected over the conferences that we had all over the world last year. 4 places, US, Europe, Mumbai and Philippines. So a lot of people had come, a lot of data was collected, things were collated. So these are the steps that we kind of got from them. So upskilling. So upskilling is something which we'll have to do anyway because the instructors, most of the instructors have not been on board for a long time and these are new tools. So we have to upskill them to actually teach. So first is the instructors and trainers. The second part is the core skills development, what I just told you. Critical thinking, hazard identification, workflows. So you have to challenge what your AI is throwing at you. You just don't have to blindly follow it. We are talking about infrastructure changes. Again, that will come, probably that could be a choice what a educational institution makes before STCW comes in, which a lot of people like Solent University and many of the European universities have taken initiative and they have started the course on this. There are a lot of running courses, about I think 6 or 7 of them in Europe. So we'll have to think on those lines till STCW says something about it. Then again, instructor training and phase rollout of the courses. So the technology requirement again, so all these things about corrupt data, about data validation will have to come in the system. Again, simulation versus live data, so we have to see the affordability, how much of thing we can do offline and how much of this we can do online. But the online part is not only the internet, it's part of to do with the subscription. So we are in talks with UKHO for giving kind of a training or educational environment for all these systems. We are in talks with UKHO for that. Industry collaboration, so manufacturers have to take the lead. So we have decided to take the lead. We are doing this since last 1 year. We started on 2024, 1st of January. And 1st of 2025, we collected all the data and now we are collating and designing a solution for that. Industry-wide collaborations, shipping companies, academia, so all these domain expertise has to come from people who are actually using it to train people who do not know it. Collaborative pathway to regulations, what I just talked about, probably some representation can be made to IMO in all these meetings that we are going in. It's an identified gap and we have to plug it. So something has to come about digital in that. Practical implementation, so these will be all customized solutions for sure. So it will be depending on data sets, it will be depending on availability, the scaling, everything will depend on how many people they want to train and how much they want to get involved with this. Connectivity, yes, and then flexible training programs. So that's about digital passage planning. So the core, I would say, key takeaways, what I will tell you is industry-wide thoughts on this, and especially policymakers who are getting involved with DG shipping or IMO as well, to think in these lines, because charts are not going to be available. Next few years, you won't get in charts anymore. So the syllabus has to be changed, we all know it. How you want to change it, how you want to phase it, that's something which we have to do. Partly we have done it in the software, but then again, it's a practical implementation on board and not as an academia, but we are planning to do so. So this is the first part. I will take the questions together later. Let me go to the next part. This is also something which is new. Few years back, it was just limited to national requirements. It was happening in Norwegian waters, it was happening in some other waters around the world, but it was never kind of a collective approach till IMO stepped in. So we all are talking about mass code now, right? Autonomous vessels. I'm not sure how much of it will come to India and when it will come to India, because again, we have time, next 5-7 years. But again, this is something which is, we are starting as training and we are getting involved with creation of these simulators as well. So this is coming out very soon, probably within the year. So what is MAS? So Maritime Autonomous Surface Ship. So till now, this was guided under national regulations. Germany was having it, Japan was doing it, Scandinavian countries always had a lead on it, ferries, fixed route things, so a lot of automation was there. But now with IMO involved, there are clear definitions of what mass levels are. So mass level 1 is something which we are doing right now as well. So some automation, there are people there, there is machinery there, you can attend at all times, but there are a lot of automations that you can do on board. Degree 2 is again remotely controlled ship. That also, I think a few of the companies are doing it. So remote controlled ship with seafarers on board. So they are ready to take over if something happens. Number 3 is remote controlled with no seafarers on board. And number 4 is fully autonomous. Okay? So it's like there is no interference at all. Now these are the broad dates, what I wanted to bring it to your notice. So 2026 is adoption of non-mandatory mass code. By 2028, I think it will be commence development of mandatory ones. By July 30 is adoption and by enforced by 2032. So again, next 5 years, you're going to see a lot of changes happening of people who are doing it. Again, valid for people who are doing it, but adoption will increase, specifically to do with ferries and fixed route areas and people with less manpower at first. So what is an ROC simulator? So ROC simulator consists of basically controlling of the vessel, right? So it could be a part of, say, a full mission simulator, remotely seen by a camera and being controlled from some third station, right? So there will be a ROC operator, there is a ROC fleet manager who is looking after all the ROC operators in a fleet center. So it could be a standalone training, it could be a joint operation, it could be on multiple team and multiple simulators. Key components. So an ROC operator is one who can control one or many ships. Should not be too many, otherwise it's kind of difficult to concentrate what they're doing, especially in congested waters. So he will have a video stream from bridge cameras. So as a simulator part of it, this could be a full mission bridge in which there is camera, so that the video streaming happens and all the delays and everything what is happening, any corrupt data. So that is the challenge which an ROC operator will face. So that's the whole idea, that you need to simulate all those things. He will have an option to have a feed for the ECDIS. Radar could be optional, otherwise it could be an overlay. There is sensor and propulsion system, vessel alarms, so it could be a simulator alarms obviously. VHF, so that an ROC operator can communicate the vessel, or maybe an instructor can act as a VTS center. So a full network of VHF stations working on a VTS mode. So this is the layout. So this is happening. This is a practical layout of what we are going to do in a project based out of Europe. So 3 simulators, virtual streaming of those simulators to these 2 centers. And if you see, there are 2 iPads on the table. So they can even be controlled through those iPads. Now what is a fleet management station? So fleet management station is something like a supervisor who controls all the ROC operators. Okay, so he's the decision maker and approval for a lot of these things, and he has the view of the full chart and what the ROC operators are doing. What is the value out of it? So you can train isolated teams or multiple teams, communication, challenges, what problems they could face. You can have system faults in place, whereby you can simulate what actual issues related to streaming or data lag or data hindrances that will be simulated. Again, intelligent targets, which are part of a simulator, which could simulate the unmanned, the whole experience part of it. Then we have an API which can actually connect to, so these systems are actually being connected to real systems. Let me make it clear that the ROC simulator is basically a training solution of a real system. It's not a full grown simulator. So you can see Trafficker with Sweden is the one whom we are tying up, who is a very famous name for an ROC, a real ROC control system. And the whole SIM system of transferring data and everything is done by the Brightstone software. So basically it's an integration of a real system, and the whole part of operations will be as the real system works, but we'll do it in a simulated environment rather than the real environment. So you can have a digital twin concept. So this is how the maximum setup will look like. There will be stations, there will be ROS stations, and there will be fleet monitoring stations. That's about it. So these are the new emerging technologies that I wanted to talk about. Again, with a definite timeline as defined by IMO or as not defined by IMO. So I'll be ready for any questions if you have. That's all from my side. Okay. Thank you very much. Thank you.
Thank you so much. Thank you for sharing all those very insightful learning. I must say, even though backstage, I learned a lot today. Thank you. I would like to call upon Captain Pradeep Korea to felicitate Captain Gaurav Bajaj Captain Pradeep Korea, are you here with us? Please come up on stage, sir, and let's hear a round of applause, please. Thank you. Ladies and gentlemen, your applause is what keeps us going. I know it's that time in the evening, but let's hear it again. Thank you very much for joining us. Thank you.